10.2 permutation. What a permutation is an arrangement of objects in a specific order. The formula for permutations is if I have P of n comma r, this is n factorial all over n minus r factorial. N is the total number of objects, and R is how many of those objects wanted.
Total number is R is
How many you want. Factorial. If I have 5 factorial, all this means is 5 times 4 times 3 times 2 times 1. That is what the exclamation point means. Now, I don't have to sit there on a calculator and go 5 times 4 times 3 times 2 times 1. It's 120. So there's 120 different orders I could have. The fast way in the calculator, I hit math. There's a probability section. If I press to the left, it'll flip around to it. I have exclamation point 4. So 4, I forgot to put the 5. 5, exclamation point. 5 factorial is 120. If you don't have your graphing calculator, the old ones, you just have to go 5 times 4 times 3 times 2 times 1. Math over to probability.
Wait, hold on. So what if you got a different number factorial, like 8?
8, you take 8 times 7 times 6 times 5 times. But on the calculator, just hit 5, exclamation point. So on the calculator, if it was 8, it's 40,320.
I like that.
All right, you have 7 MP3s in your playlist. So you just took all your songs, you put 7 of them in a playlist. How many different ways could you listen to just 3 songs? Now, you might see the notation written a couple ways. The normal way. What's the total number I have here? I have 7. How many do I want? 3. You might see it like this, or you might see it like this. They mean the exact same thing. All right? I use the formula. N factorial, so 7 factorial over 7 minus 3 factorial. Now, what 7 minus 3 is? 4. Now, I'm going to show you mathematically how to do it without a calculator. What's 7 factorial mean? 7, 6, 5, 4, not 2 4s. 3, 2, 1. 4 factorial means 4, 3, 2, 1. What do you notice? What repeats? So that cancels out this, right?
Yeah.
So what do I really have? 7 times 6 times 5. Well, what's 5 times 6? 30, and 30 times 7? 210. There are 210 different ways. That's doing it by hand without a calculator. Now, I could have easily, just in the calculator, went 7 math over to probability 4 divided by 4 math probability 4. Gets me 210. Either way works. If you understand what I did. Here's this problem. On a baseball team, 9 players are designated as the starting lineup. Before the game, the manager has to announce the order in which the 9 players will bat. How many different batting orders could the coach use? Now on this problem, how many batters do I want? Or how many players do I want? I want all 9, right? Now I'm not going to sit there and use this formula. The reason why? I need all 9. So for this problem, it would be like if I had 7 and I'm playing 7. All I'm going to do is take 9 factorial. Because I'm using all 9 options, it's 9 factorial. 9 math, probability, 4. Enter. 362880. There are 362,880 ways the manager could change his lineup. That is a whole lot of ways. But that's every possibility. In baseball, you want to make sure you have your best player in the correct position. That way, you're most likely going to score runs. What's the question? Right. That's another, yeah. That's 9's the only number in there. So when you're talking about how many different things are happening, that's a permutation. How many different ways could I light up 5 guys and 8 girls? This problem is different than the other one because I am talking about guys and girls, 2 different sets. But they're identical objects. When they're identical objects, use the formula n factorial all over r1 factorial times r2 factorial times whatever, r sub k factorial. That looks very confusing. All this means in this problem, this is the total. These are the individual pieces. Okay. What's the total amount of people I have? 13 factorial. All over. So it's 5 factorial times 8 factorial. It's just however many. If I said 5 guys, 8 girls, 4 dogs, 3 cats, 2 chickens, I would add up the total number of whatever I have, all over each individual one, factorial. This just means if I had k number of things, that's how many. Here I only had 2, so there is no RK. But if we're talking about guys, girls, and Tysons, it would be R1, R2, and R3s. So I have 13 factorial. Divided by, now I'm going to put it in parentheses. Did I accidentally delete that? 5 factorial, 3 factorial. Are you with me up to now? Or 8, sorry. I couldn't see the problem. Yes. There. My ghetto 8. Divide, and I get 1,287 different ways. There's a lot of different ways.
So let me get this straight. The only difference really is that you put that together.
This is you're taking 2 separate things and putting them into one group. All right? These ones were just one group. How many different ways? This was taking one group and breaking it apart. This is taking pieces and making one group. The one final way. How many different ways can 6 people sit at a circular table? So some of your lunch tables are circles. If there were 6 of you, how many different ways could you sit? For circular permutations, it's a different formula. N minus 1 factorial. And that's it. 6 minus 1 factorial. So how many people are there? There are 6 people minus 1 is 5 factorial, and we did 5 factorial at the beginning. There's 120 different ways you could sit at the table. What's that? Yeah, if it's ever talking about in a circle, that's what you use. It's a circle? All right. If I said, I'm going to take 6 people and I'm going to line them up. And I have positions 1, 2, 3, 4, 5, 6. I have a beginning and I have an end. But if I said I'm going to put you in a circle, where's the beginning, where's the end? So I'm taking off the positions of beginning and end. That's the difference.